So let's talk about displacement. That's the next area that we're going to discuss here. Displacement is the process of using a texture to force the surface to bump. And whereas a bump map is usually a trick of light, where it's basically it looks like the surface is bumpy, but it's usually a trick of light and shadow. And as soon as you move into a profile, the surface no longer has a bump; it's always lost. You can keep that profile bumpy by using displacement. Displacement will actually displace the profile of an object because it's tessellating that object up. Having said that, obviously by creating more tessellation within the scene, it's going to be a lot more expensive to render. So Mental Ray gives you the ability to use a special kind of tessellation called fine tessellation, which will create a very optimized set of polys that represent the surface, and it will render much denser distributions of polygons within your displacement at a much higher rate. So let's take a look at how this is initially set up here. I just have my, it's just a default surface, it's a NURB surface, nothing special about it. I could be using polygon, I could be using sub-D surface, this will work with anything. And I have my Lambert shader, which is just a standard Lambert shader, and if I step backwards one node into the shading group, I can see that I do have a displacement material attached to it. So let me go on ahead and map this node out, and you can see what the connections are. I am using a layered texture, and we're going to get into this more on disk 2, but the idea is that I'm first using a bulge, which is going to give me a nice uniform distribution of a bulge, and then I'm using a fractal layered in there as well, and that's going to give me some noise within that bulge. And you can see these two things layered together. Bulge is layered over the top of fractal with a multiply node. And then both of these things are layered into a ramp shader, so I can derive a uniform luminance channel that is going to be used as the displacement. And we'll talk about why that's doing that here in just a second. So initially, I'm going to select my surface, and I'm going to go to my approximation editor, and I need to assign to this surface a displacement node. And the reason is that I don't want to use Maya's displacement stuff, either feature-based or non-feature-based. I don't want to use what Maya provides as displacement, because Mental Ray provides a kind of displacement, like I said before, called fine displacement. And what that's doing is that it's allowing the surface to be broken up into sections before it is tessellated. Normally, when a surface has displacement applied to it, the entire thing has to be tessellated and loaded into RAM at once, which means that if we have a very complicated surface and we apply displacement to it, you could have theoretically millions and millions, possibly billions of triangles. And that creates an extraordinarily high memory footprint, and it might be impossible for the machine to process it. So in order to deal with this, they've come up with this fine approximation method, and what it does is it allows Mental Ray to build subsets of the surface, and each one of those subsets is tessellated and rendered independently. So maybe each one of these surfaces broken up into a quadrant, I could have a million polygons right here in this section, but it's going to render this at one time. It's not going to have to tessellate the entire surface, and because of that, it achieves much finer levels of detail in this one little quadrant at a very small memory footprint. So in order to assign a displacement approximation, I'm going to select my surface. I'm going to go into Approximation Editor. Under Displacement Approximation, you can see NURBS, polys, or sub-D, and I'm going to tell it to create, and then I'm going to edit the approximation that was created. I'm going to go under Presets, and I'm going to go Fine View Low Quality. So under Fine View Low Quality, you can see that the approximation method is spatial and the approximation style is fine. And we have minimum subdivisions, max subdivisions, length, and sharp, and also view dependent. So what's happening is that you have the minimum number of times a triangle can be subdivided on the surface and a maximum number of times. The same thing is adjusting the image qualities. The higher the number of subdivisions is, the finer the detail will be. And then the length setting. If you have view dependent turned on, then the length setting is relating to pixels on the screen. If you have view dependency turned off, then the length setting is relating to object units within the scene. So normally I'm going to have view dependency turned on, and it means that no triangle will be longer than 1/2 of a pixel in length in the scene. And so as I lower this number and as I raise this number, the approximation levels will become finer and finer and finer, and giving you much higher levels of detail. So I'm going to go ahead and render this section out. There's my surface. I'm going to hit render, and there's my bump. And you can see it's very nice and uniform. The bump is very, very smooth, or the displacement rather. Now, the displacement value that is being applied to the surface is coming via the color balance node, alpha gain. The higher this number goes, the higher the bump is going to be on this surface. So if I set this to 2 and I render this guy out, you can see that the bump level goes up, so on and so forth. So the higher this number, the higher the bump. Now, in terms of the actual bump itself, the sharper the texture is, so the more detail that is in this luminance texture, the more detail is going to have to be in the map that you're representing. So the higher the tessellation values are going to have to be within your approximation. And all that means is that if you have a lot of detail within your displacement map, or you have very sharp detail within your displacement map, you will have to tessellate down to very low levels in order to get this to work. So now, getting back to the reason that I have this ramp texture in here, I'm going to go on ahead and assign my ramp texture into my displacement shader. A lot of times you'll want to use a layered texture node because it's a nice way to design textures within Maya, and maybe you decide that having used just a bulge or just a fractal, you're not really getting the results that you would like to have, so you need a way of layering these things together, and to do that I'm using a layered texture. The problem with the layered texture is that I don't have a uniform alpha output, and because it is using the alpha as luminance on these texture, alpha is luminant, on this layered shader I have this overall resorting alpha value, but I don't have an alpha slider that adjusts everything within this node. I can only adjust individual objects or individual levels at once. So in order to give myself a clean alpha value to adjust, which will help me to adjust the overall bump on this surface, I've mapped it into a ramp. And on the ramp node, I've killed all the other level inputs, and I've just mapped this layered texture up here into my one color input. So my selected texture, you can see that I have something mapped in here, and that is my layered texture. And by doing that, I've just simply given myself, under the color balance, a new alpha gain that I can adjust. So now I've got 2 levels of control on this, this texture. I can either come into my layered texture and adjust the amount that each one of these guys is in here. So maybe I'm going to turn my fractal so it goes down, or I can turn it up. And then I can go into my ramp and I can say how much I want each one of these guys to bump. So let's go on ahead and kick this render off and see what happens. You can see that we're starting to get a little bit of bump and displacement within this surface. We obviously have the roughness in here that we didn't have with just the bulge. I'm going to go on ahead and go into my ramp and increase my alpha gain up a little bit and see what happens. Starting to go up again. Do it some more. Now it's getting very high and the displacement looks fairly nice. Now, one thing to point out is that if you were to be doing this with Maya for starters, this renders would take exponentially longer than this. These renders are going by very fast because of the fine approximation method. We still have some artifacting in here. I have some real sharp jaggedies that I would like to resolve, and I can do that by adjusting the approximation editor. So let me grab onto my surface again, go into the approximation editor. I'm going to grab onto my mental ray displacement approximation node 1. And I'm going to tell it to edit. I'm going to start by upping the maximum subdivision levels. I'm going to set this to a 6, and we'll see what this render looks like again. Now, the higher up you set those numbers, the more you're asking mental ray to tessellate, and these renders can become very, very expensive, but it's still cranking out a beautiful displacement rather quickly. I can go on ahead and go up to 7 again just to see what happens. Edit 7, and take a look at this one more time. So you can see what this looks like with a level of 7. So there's a level of 5, there's a level of 6, and there's a level of 7. It's beautiful displacement. This particular texture, because it is a procedural texture, it's going to be able to resolve this to extremely fine levels because of the fact that it's a procedural. Theoretically, these levels will just continue to increase as we increase those numbers. So let's take a look at a more practical application of this. Displacement ground. Now this is just a simple scene with a deformed NURBS surface. Create a new camera here, so I have something to look through. Nothing special about it. I do have a displacement map that I'm going to assign if I haven't already. And if I ask this surface or this map to map out, we can see we have a couple of different things going on here. I have a surface texture that's being pushed into a layered texture, and that looks like it's going into diffuse. And I have another one that's going into ground color. I have a displacement texture, and I have a bump node. It's a good idea sometimes to include a bump node even though you're using a displacement, because sometimes super fine levels of detail, like the little tiny minutia stuff that might be present in, for example, sand, can be represented with a bump, but you don't necessarily need to see the profile of that. So I can use a rougher displacement map to get the overall surface shape correct, but I can use a nice fine bump map to get some of that interior detail. And so I always make sure I include a bump map in the texture there, so I don't, again, use up unneeded amounts of memory and time calculating a displacement map that I could get another way. Because even though these are rendering very fast, they're still quite expensive to render. And then my displacement is coming straight off of this texture. So let's make sure that I have a displacement approximation assigned to this surface. So I'm going to go to my MentorRay set of tools, and I see that I don't have one yet, so I'm going to create one. Create. And edit. So again, I'm going to go to presets, fine, low quality, and I'm going to start off here and see what happens. So there's my resulting render. It rendered this image fairly quickly considering, and we have some nice deformation and detail. I obviously have some rendering artifacts in here that I need to smooth out. So I can come into my render globals and attempt to smooth those things out. Not with the render globals, I'm sorry, with the approximation editor. So let me hop into approximation editor. And I'm going to go to edit. So up the maximum subdivisions, and then I will render again. And again, I can't stress enough that as you start to increase those maximum subdivisions, the quality of this render will get very, very nice. It'll also get very, very expensive. So everything is rendering through nicely. I'm going to try this one more time. This time, instead of increasing the maximum level of subdivisions, I'm going to increase or decrease the length from 0.5 to 0.25. So let's go on ahead and see what that looks like. In the same way that sometimes tightening up the samples by adjusting the contrast threshold, sometimes it's a good idea to sort of try and do that same kind of thing on your displacement with the triangle length, because it's just a bit cheaper for it to render. So here you can see that it's starting to get some very nice detail, and the surface is being very well defined. We still have a lot of real jaggedy bumpies. We just need a lot more tessellation. Now, here's one thing to consider. If what I was trying to go for is a nice lumpy surface, I obviously have some high frequency information within this map, which means that I have some noise in this map, okay? So if we take a look at this displacement map, what you can see in here, there's a lot of high frequency information. So I have a lot of variance in here. And while MentorRay can certainly displace this, we can tessellate to the point where we can see all of this information. It's not necessarily ideal because I'm trying to represent an awful lot of information with a very dense displacement map. And so I'm going to have to tessellate it to a very fine level in order to record a lot of this incidental detail. So what might be a better idea is to first blur this map a little bit and then push some of the values a little bit so that I get dark darks and light lights, and it'll give us a much finer tessellation within the scene. So let's take a look at our next example to show you something that has had that exact treatment applied to it. And this is going to be using a DEM, a digital elevation map of a surface, to render us out a view. And again, all it's doing is we have our surface, we have a basic shader that's been applied to it, and that surface is being displaced, and that's all that's going on with it. If I look into my attribute spreadsheet or my approximation editor, and I get into my MentorRay displacement approximation, I can see that we do have some very high settings in here. The maximum subdivisions is set to 7 and the length is set to 2.25, and that's going to allow it to resolve to a very fine level. Let's go on ahead and do a render of this guy. So here you can see a very beautiful rendering of this DEM map, and it's getting very fine tessellation approximation because of the settings that we have in here. Again, we had 7 as maximum subdivisions and a length of 0.25. Generally, you would not want to set this minimum subdivisions beyond 0 unless you were getting tessellation errors that were showing up as big boxes or something like that. Or blank areas within the scene, because you want it to be able to use 0 or only tessellate once if that's indeed going to result in the appropriate tessellation. You usually don't want to force it above its minimum if you can avoid it. But a maximum subdivision level of 7 and a length of 0.25 gives you a very, very detailed image. Now, one artifact that we haven't run into that you may run into sometimes is that this is a NURB surface that's being tessellated with this, and sometimes those NURB surfaces will not tessellate correctly, or they will get big black stripes running through the surface that are both not shaded and also transparent. And there seems to be some kind of a translation error between MentorRay and Maya, and to get rid of those problems, if you simply assign a surface approximation to that NURB surface, it will get rid of that artifact. It'll return the tessellation back to what you expect it to be, and it'll get rid of that big black grid that seems to be projecting through your scene. Also, if you're working with a polygon object and you have tessellation errors, like I was describing on the NURB surface, if you go to Windows, UV Texture Editor, and you make sure that the entire surface is existing between 0 and 1 on the grid, that should alleviate those problems also. But sometimes, if you have your UVs that are way outside of this grid, you can get tessellation problems where these objects reach the boundaries of the grid. So simply scale your entire object within the boundaries of this 0 to 1 grid, and you should be good to go with that. So, beautiful displacement with fine displacement. So the last thing I want to cover with regards to displacement is using a utility node to help us get displacement to go multiple directions on the surface. And what I mean by that is, normally when you apply displacement to the surface, it's going to start where the surface begins and it's going to bump upwards. So for example, if we had a NURBS plane and I applied displacement, basically the displacement is going to go up. It's not going to go down, it's always going to go up. Unless you tell it to use a negative displacement value, and then it will go down. But sometimes you want it to just go up and down and leave the center line of the surface where it's at. And in order to do that, you just use a utility node and pass the appropriate values through. So I just want to take a look at doing that. So I'm just going to do this with a regular NURBS plane. I'm going to step over to our MentorRay shelf, and I'm going to pull up the approximation editor, and I'm going to create a new approximation editor for this plane. The approximation that we want to use, again, is fine view, low quality. And I'll just bump this up to 6 and 0.25. And then I can go design my shader. So I'm going to open up the Hypershade there. And here's a Lambert shader. And I'm going to import a file that we'll use for our displacement. Let's see here, disk 1, ground, using the .map filter file format because it's faster. And then, in terms of the nodes that I want to use, I'm going to use a set range to establish a positive and a negative value. And then I have to pass that set range information through a luminance node in order to derive a single luminance channel. So the file node is going to go into the set range is going to go into the luminance, and then the luminance is going to go into displacement. And the last thing I need on this surface is a displacement shader, so I can go on ahead and just generate a random displacement node. I'm really just trying to get this guy, so I can delete those. I have this displacement node which belongs to this shader. And now inside of the displacement node, I'm just going to set this up. So initially the file is going to go into the set range, and I'm just going to go into the value. Okay, and if I open up the set range, you have a couple of different options here. You have your minimum maximum, which are going to be the new values that we establish, and you have your old minimum maximum. So initially my old minimum maximum are just going to be the old minimum, which was 0, and the old maximum, which was 1. Now the new minimum is going to be a negative 0.5, negative 0.5, negative 0.5, and the new maximum is going to be a 0.5 all the way across. Okay? So now I have to, like I said before, your displacement is looking essentially for an alpha value. So it's looking for just a luminance value of this file. What is going to be passed over the set range is going to be a vector. So it's going to be either an RGB or an XYZ kind of information. So I have to convert that into luminance. So I'm just going to take this set range node. I'm going to pass it through the RGB to luminance, which will give me just a value output. And then that can go into the displacement. So I'm going to use the out value from my luminance node, and I'm going to place it into the displacement value on the displacement shader. And that's already hooked up to this initial Lambert. And then I'm just going to select my surface, assign the Lambert to it. And now if I do a render, you can see what we get. And just to prove this point, if I sort of come onto a oblique angle here and I render this out, I'm going to save this image. Now, if I go back into my hypershade and I take the alpha values just coming out of the image now without passing it through the set range and the luminance, and I map that to displacement, and I render that image out. And if we just do a compare and contrast between the two, you can see that the one that's going through the set range and the luminance node is sort of right in the middle, and the one that's just generating off the value node is right up at the top. So that's how you can get your surface to displace somewhere in the middle as opposed to above the surface or below it. So that wraps it up for Disk 1. Look forward to Disk 2. On Disk 2 we're going to be getting into lighting and shaders and shadowing, so that'll be something to look for. Thank you.